So in this video series, we're going to be taking a look at the different surfaces that might exist in space, and I'm going to show you how to sketch them freehand. I'm also going to show you how to sketch them using technology, and then we're going to take a look at a specific type of surfaces called set of surfaces called the quadratic surfaces in this section. Most of the time in real life, you're just going to use some sort of technology to be able to graph your surfaces, all right? But we should have a good idea as to what surfaces at least look like if we were to just be given the equation. So that's our first aim. Generally what you do is you just think about what's dependent and what's independent, and then try to sketch from there in 3 dimensions. All right, so we're going to go through 4 examples just to take a look at this, one of which is very familiar. All right, so just to kind of get the juices flowing on this again, we have this vector, I'm sorry, not vector, excuse me, we have this plane y equals 3. All right, and we know it's a 3 because remember in the very first section we were going to plot those. Now I want you to notice it says nothing about x and it says nothing about z. So we know that x is in real and z is in the real numbers as well. Right? So when we plot this, x and z can be any numbers, but y has to be 3. So when we graph it on our 3-dimensional plane, so remember this is x positive, this is y positive, and this is z positive. Now y has to be 3. Right? X and z can be anything. So you may recall that we just sketched a plane, right? And again, that plane just runs infinitesimally through y equals 3 in all directions, up, down, left, and right. Now, not every surface is a linear or planar type of surface. So for a second example, we have z equals x squared. Now we know that z equals x squared is going to be some sort of parabola, but it doesn't say anything about y, and that's because y can assume any real number that it wants. So basically what that means is that we are going to expand the shape in the xz plane along the y-axis. Right, and I'll show you what that means when we graph it. Right, so let's go ahead and graph this. Right, so if I was to graph it once again, now all we care about really is the x and the z. Right? Now notice that the domain for z has to be greater than or equal to 0. So we're always going to be above the z-axis. Right? But z is going to be dependent upon the value of x. So maybe we could plot a few points in the xz plane, and I'm also going to make an x negative. Right? So we know that 0, 0 is one of the points automatically in the xz plane. We know that if x is either positive or negative 1, that z is also going to be 1. And so what we get, I know this is a very poor drawing, but just go with it for me, is we get a parabola that passes through those points. So let me try this again. So we have this, and we have this. However, what's going to happen is that it's going to expand on the z, on the y-axis. Right, so let me try to draw this again. Alright, so I'll just do this, and then I'll throw the z-axis in there, make it nice and easy. Now we know this is going to expand upon the y-axis, so we're just going to draw a parabola and just kind of link these together. Right? And that's what our surface looks like. Okay, so it's a parabola, and you're just going to stretch that parabola out indefinitely. Right? When we use technology, we'll get a little bit better shape than what we did here. All right. A third example, x squared plus z squared equals 25. So once again, similar to the previous problem, y is independent, and it can be any real number. And so we know that x squared plus y squared equals 25 is going to be a circle in the xy plane. However, this is going to be a circle in the xz plane, and then we're just going to expand it, okay, of radius 5. Right? So let's just go ahead and construct that as best as we can. So let's just assume that this is x positive, this is z positive, this is y positive. And here's our circle on the xz plane. Right? And then we're just going to stretch this out. And so what we end up getting is we get a cylinder that's basically going, and the y-axis is going to skewer that right through the middle. All right, so I know my construction's not all that great, but you guys can visualize how that's going to work. One final example, z equals e to the y. Now in this case, x is any real number, so we're really just going to be plotting in the zy plane, or the yz plane. And in the yz plane, we have the relationship that z equals e to the y. So I just added e to the y to both sides. What we could do is we could just throw a few values in for e to the y, or just for y, excuse me, and then try to evaluate. All right, so this is going to be our z positive, our y positive, and then the x positive. And similar to the other problems, this relation is going to expand upon the x-axis, not the y-axis. All right, so if y is 0, z is 1. So we have this point right here. And then we know if y is 1, we get e. All right, so we kind of get this shape, and I'm going to expand this. Okay. We're going to end up with this relationship. And this is going to stretch out on the x-axis. So I'm going to draw another one of those sort of shapes on the along the x-axis and just stretch it out. And this is the surface that we get in 3 dimensions. Right? So these are actually fairly easy types. You just graph it in the correct plane, all right, with the relationship, and then you just stretch it out along the axis that does not necessarily have a dependence upon the other variables. Now, there are some times where we're going to have relationships between all 3 variables. In other words, a function of 2 variables. All right, that's going to come later in the course. But for right now, we're just getting some of these basic surfaces. In the next video, I'm going to illustrate how to utilize technology to be able to graph these. All right. So if you don't like graphing these by hand, hopefully you can get an image as to what they look like. And if you can't do that, then you can use technology.